All right, hello and welcome to today's SQL Office Hours. It's great to be back here and help answering your questions about SQL. And today we're going to dive into a topic that I've covered various times in the past in various presentations, but I think we've had 2 or 3 sessions now where we've done this visualization showing how things are actually interact with SQL. When you select things, how that affects the result set. And following from comments and feedback from previous sessions, decided we'll do this with Match Recognize, and we'll say, look at how Match Recognize row pattern matching works. Now, before we kind of get into this, the usual disclaimer and the kind of warning on this, the real power of pattern matching comes from regular expressions. So be warned, there will be regular expressions in this presentation, right? As I say, if you've got a problem and you decide to solve it using regular expressions, and you've got 2 problems. So okay, I promise you we'll keep it as basic and as simple as we can for this session. Just be aware, to really unlock some of the full power of pattern matching, you kind of really need to get to grips with regular expressions in themselves. So if you're not up to date with those, check out, find something else to read up about them. We'll keep it simple for today, so hopefully we can all follow along. So, hi everyone, I'm Chris Saxon. I'm part of Gerald Benzel's developer advocate team. It's my job to help you get the best out of our Oracle database and hopefully have some fun while doing so. So that's why it's always great to be here doing these office hours sessions, answering your questions, discussing how SQL works, and hopefully learning something along the way. To help me today, as previously, I've got Christian again. Hi, Christian.
Hello, welcome everybody.
Is my resident Oracle Analytics Cloud expert to kind of help me build the actual visualizations, show hopefully how things fit together in a bit more detail. So thanks to him now, able to put this together. Actually, I leaned on you a lot more for the window functions one, what was it, a couple of months ago, wasn't it? That was a bit more of an adventure trying to create, wasn't it?
Yes, that was funky, yeah.
Yes, yeah. I am super glad you were able to help me with that one. Alrighty then. So let's get into this. So before we kind of get into some of the details, just some kind of overview things about pattern matching or Match Recognize. So the first thing to note is when you're using it, it comes immediately after the table name. So what that means is the table is the input to Match Recognize. Now, of course, when I say table, everything in SQL is a table. So it could be a view, it could be a subquery, it could be a pipeline table function, that kind of thing. Anything which returns a result set. So that is the input to Match Recognize. We'll do some processing on the data there, and that will define the real result set. So the final table, the result, is what Match Recognize outputs. One of the interesting things about that is, if you've got a where clause after this, it's actually the result of the Match Recognize that where is processing that applies to, not the input table. Okay, we're not going to get into that too much today, but just a little thing to be aware of. So the table is the input, will process the data and generate the table out of the output. Now, within Match Recognize, there's a whole stack of clauses, and it looks a little bit like this. And at this point, it's like, oh God, what's going on here, right? So we're just going to go through these fairly quickly. Okay, just give you a glance about what they're about. So there's 5 key clauses we're going to look at. First up is the order by. And unsurprisingly, a bit like order by on a select statement, it sorts the data. Now, this is a technically optional clause, as in you can leave it out of the statement and it will still actually execute, but it is almost always necessary. It's almost always needed to get the result or guarantee the result that you want. Hopefully, if you've got a select statement without an order by, the rows could come back in any sequence, and you're probably not going to get the result you're looking for. It's the same with Match Recognize. Without that order by, you don't know which sequence was processing data, probably not going to get the result we're looking for. And we'll actually see some examples of how this can affect the output as well. Next up, we have the measures clause, and this defines output columns. So we can use expressions here to say what we want to be in the output. Now you'll notice I've got 2 things here, classifier and match number. So they are inbuilt functions for match recognize. And they're going to be super useful for this presentation to help show what's going on, but they are also super, super useful when you are writing pattern matching queries. I thoroughly recommend, no matter what you want the final output to look like, is you include these, because classifier returns the name of the pattern variable that the row matches. If you don't know what that means, don't worry, we'll get to that in a bit. And then match number is the number of the group. So this will group rows together. Starts with 1, so we'll go group 1, 2, 3, and 4. We'll see in a bit more detail how these work in the future. There's lots of other things you could add in the measures clause here, but these are two key things you probably always want to add when you first start writing a match recognize query, just to kind of get to grips with what's going on and help you debug and figure out what's going on. Next, we've got this all rows per match. Now, again, this is an optional clause. We can exclude this, but if we do that, then it groups the rows together into one. So by default, it's one row per match. So if we've matched 10 rows, like group by, we just get one row in the output instead of 10 individual rows. Again, for the purposes of what we want to show here today, it's going to be useful to see all the actual individual rows, but also when you are debugging or first writing these queries to start with, it is super, super useful to put this in so you can actually see what's going on. It can be quite tricky to understand once it's clapped things together. So hopefully these are fairly obvious, fairly understandable. Next, we come to the real kind of core, the real engine of pattern matching, and that is the pattern clause. So this is where our lovely regular expression comes in. So we're going to have some pattern variables and regular expressions involving those. We're going to see lots of examples how this works. And of course, if we've got pattern variables, what are they? What do they mean? We need to define them, and we do that in the define clause. Yeah, hopefully relatively obvious what these mean, but again, you know, when you first look at this, you kind of like, what the heck's going on here, right? And I remember, Christian, your face when I was showing you some of these, you were just like, it was interesting, shall we say, right? So that's the quick overview. Those are the 5 things we're really going to look at, and actually, really, it's only 4 that we're kind of interested in today, because the all rows per match we're just always going to leave on, basically. So at this point, you might be going, okay, well, that's nice, but I'm more confused, right? This hasn't actually helped me in any way at this point. You're like, well, what's still going on here? How do I figure out what the situation is? So let's actually get started. Let's get started and look at some examples in a bit more detail. So those of you who've been following or watching me for a while know, and I kind of like running. So again, we'll use an example of analyzing some running training data. And the first thing we do is really super simple. We'll just try and pull out all the runs which are 1 kilometer long. So all the times that I ran a distance of 1 kilometer and then stopped. So at this point, we will jump over to the demo and actually see some of this up and running, see some of this in Oracle Analytics Cloud. So let's just do this. So I've got my match recognize clause here, and the key things to note here is I've got my pattern. I'm saying 1 km, 1 kilometer. Well, what does that mean? Well, I've defined 1 km as the distance equals 1. So that's just like a normal where clause. You know, distance in kilometers is a column in the table, where kilometer for distance equals 1. It's exactly the same principle. And we're finding just exactly 1 instance of those. All right. And we're matching it multiple times. So what happens is we've got our data set over here. So this is our input table, running log, or whatever it's called. And we've got our dates and the distances. So we'll start with the top row, and we've sorted by run date. So we'll start and walk through the data set in run date order. So we start with the first one that's got distance of 1. That matches the condition. So it matches the group. So if we close this, we will see that we've kind of highlighted the row over here on the right. We then go to the next row. So this is a distance of 5. Obviously, that's not 1. So I've kind of hatched it out here to show that would be excluded from the output. So you would not get this in the results. I'm just hoping this kind of makes it a bit clear. You know, putting these things, showing them all over here on the left is our input. Over here on the right is the output. Everything that's hatched out would be excluded from the output. But I think just having them side by side can be make it a bit easier to see what's going on. I hope it makes it easier anyway. So we can, as I select them, we can see a kind of one-to-one matching. So we've got that one. 2nd of March doesn't match. 3rd of March does match, and we can see that's got distance. Again, 6th of March doesn't match. And then we've got our group here, or our chain of 1 kilometer runs. Now, the pattern matches exactly 1 row. Okay, so once we've matched this row here on the 7th, that is in the 3rd group, we finish the pattern. So we'll go to the next row and start searching for the pattern again. That's 10th of March. That forms a new group. So notice that the group here, a match number column, increments for every single time because we're just expecting 1 row in the group each time. So far, hopefully, relatively straightforward. And at this point, it is pretty basic. And really, you could have done the same with a where clause. You know, I could have just said where distance equals 1 and maybe added like a row num or a row number function to add the group and just hard coded this variable name in the output as well. So notice this bar column, 1km, matches the name of the variable in the pattern. So, you know, at this point, it's not that different. It's basically the same as just, you know, select star from table where distance in kilometer equals 1, adding some columns to the output. You know, so you might be, well, what's the point in this? Why are we using this? Well, I said starting easy, starting basic to kind of try and get the principle. So far, we're matching 1 row at a time. But as I said, we've got this chain of 1 kilometer runs here. What if I want to change this and find a group of consecutive 1 kilometer runs? So I want to lump all of these together. Well, in order to do that, we will have to change the pattern. So let's move over to the next one. So I've got a new pattern here, and I've added the little plus operator after the variable name. So this is a regular expression plus operator, 1 or more matches. So basically, we start a group and keep adding rows to it as long as they match this criteria, the distance equals 1, okay? So this is very similar to the previous output, but now these 3 rows are 1 kilometer rows, all consecutive, so they all get lumped together in the same group. So we expand this out here, you can see they're all in group 3. So rather than starting a new group for each one, we've chained them together so that they become 1 group. So already we're doing something that's actually quite interesting, a bit more powerful. I mean, arguably, you could do this maybe with group by. We'll just group by and then count the rows in the group, potentially. But what about these gaps, right? Well, okay, a bit more complicated, isn't it, right? We'd have to do some processing. We can't just group by the distance and count, because that would give us 5. So notice we're already doing something that's a little bit more interesting than just standard SQL offers you. So that's if we want to chain them all together. And we've got plus to say 1 or more. So we could do other types of regular expression quantifiers. Now, the one you might be familiar with is the curly braces syntax, which specifies how many matches that we want to find. So let's change here. And this is just kind of illustrative principle, really. What I'm saying here is curly braces 2 to 4. So at least 2 or at most 4 matches of this pattern variable, this token. So I need to find all of those. So we do that, and the first thing you'll notice is my 1 kilometer run at the top no longer matches anything. Why not? Right? Because it matches this distance in kilometers equals 1 criteria. So why doesn't it match? Okay, well, as I said, when we're walking through the data set, we walk through the data set ordered by run date. We start with the first one, ask, is its distance 1? Yes, that's distance is 1. We then go to the next row, 2nd of March, and ask, does then that match the distance equals 1? No, it doesn't. It's a 5 kilometer run. we only return rows that match the entire pattern. So we've just got one here. We need at least two. So we've excluded both of these from the results. Okay. So that is why this 1 kilometer here and the one on the 3rd of March as well, that one gets knocked out as well. It's only when we get down to this group of 3 in a row that we actually get them in the output. And actually, if I had like 5 in a row, they would also be excluded because we'd match 4 of them. And then the 5th would actually be excluded from the group as well. So just to then kind of reinforce the point about this sorting. So far, we've been sorting by the run date. We could sort them differently. I could sort them instead by distance. So let's just do that. So here I've first sorted by distance, and then I'm sorting by the run date. So all the 1 kilometer runs are going to be next to each other in the data set now, sorted by date. And I'm having one or more matches of those, so a little plus operator to find those. So notice in our output, we've got all those 1 kilometer runs next to each other. And because I've said one or more matches, they all get lumped together into this group. They've all got a group of 1 in the output, okay? So previously, they were split into different groups because they were separated. There was dates in between them. But now, having sorted by distance, they're all next to each other in the results. So they all get stuck together. Whereas with the sorted by date and the plus operator, they could actually end up in different groups. So to kind of finish on this 1 kilometer stuff, I was just going to put them all kind of side by side to hopefully share in a bit more detail how they all compare and look against each other. So we've got our just 1 kilometer on its own, our 1 kilometer, 1 or more, 2 to 4 1 kilometers, and then 1 or more 1 kilometers, but sorted by distance over here on the right at the end. And although they're all similar outputs, they all do give slightly different results. So you can see that with the 2 to 4, we're only getting these group of 3 here together. And this is the only group that appear in all the result sets all together. So that was kind of like, that's like the beginner step, the beginner, let's get going and see what we think. So questions or comments, or has anyone got any questions or comments on this at this point? You still following on, Christian? You like,
no. I was just checking the Q&A in the chat, but they're both empty for the time being.
Yes. What about the num column from Martin? Good question. So if we just kind of, I'll pop back to the distance here. So we notice we got the count star. So count star is like the count function we all know and love. Count the number of rows in the group. And you can see this is telling us how many rows there are in the group. I've also got this keyword final before it. I will come back to that towards the end of this session. I'll talk in a bit more detail about why I've put that final keyword here. But count is just like a regular count that you would have for group by. How many rows are there? Or how many, we could put an expression here, how many non-null values are there for the expression? And one of the things to note here is you can put pretty much all, like, most of the aggregates. I think there's some which aren't supported, but certainly all your standard ones, things like sum, min, max, average, those kinds of things. You can all use them there to kind of summarize your data and get some information. So that, like I say, I'll explain that in a bit more detail later on, but that's where that comes from. All right. Is there any other questions or comments at this point? In the previous slide, the sort by distance run date did not group all 5. What do you mean it didn't group all 5? Why in this patterns one, I mean, they are all in the same group. You notice they've all got a group of 1. I've just applied a different sort to the output. That's just to make the sorts actually match, so we can see it all goes across and they're all the same. Imagine I put an order by on the outer query. I put order right by run date. That's really what I've done here. They are in fact all in the same group because you can see they've got the same group number and the same number, there's 5 rows in that group. And there's probably just another kind of general principle about SQL and stuff as well. As I was saying, SQL selects without an order by can return some unexpected results sometimes. The pattern matching has grouped these all together, but if we've then sorted the rows differently for some reason or another, or somehow, that doesn't necessarily mean they're going to be next to each other in the output, okay? So we pass them to the input, it figures out what's next to each other and generates the output, calculates these values, but we can still change the sorting after the fact, which could be a bit confusing, right? And which is probably why it's coming from. You were showing all 5 together before. Yes, on this one. Yeah, again, that was just to kind of help make it a bit clearer what was actually going on here, because I was sorting by distance. So you can see all the 1Ks are here, and then we've got the 5Ks next to each other. The principle still holds though, right? Match recognizes sorting. The final output, query output sorting can still then be different, okay? So just be aware of that. Would you be able to display other, oh, God, they're coming in quick today now, aren't they?
Yeah. Oh.
Okay. I'll start with hands. Will the 2 to 4 match the first 4 and leave the last one out if you sort by the distance in kilometers? Yes, that is what would happen. Because so if we're on this example, 2 to 4, we'd match these 4 here. I'm trying to select and it's not letting me do that. But I would match those 4. That would form a group. We then go to the next one and ask, is it another 2 to 4 group? Well, it's one on its own, so no, it doesn't. Okay. So good question. Yeah, but yes, you're right. We'd match those 4 and then try and start a new group from the 5th row, which would fail. Okay. Would you be able to display other columns data from the underlying table? Yes, you can. So there's various ways. So when you have all rows per match, you get all the underlying columns from base table. Okay. So when you said all rows per match, you just get the table plus anything you've defined in the measures here. If you if you haven't done that, you only get the columns in the measures, the order, and partition by. So what you've defined in match recognize itself, basically. So the short answer is yes, you can. Exactly how it appears depends on what you've done, right? Defer till later if you want. In the 1 kilometer plus example, num equals 1 in, maybe I've just, num equals, no, so you mean in this one, 1 kilometer plus, num equals 3, because there's 3 rows in the group, right? There's 3 rows in the group, so we've counted all 3 of them. So that's why that is. An example with 2 to 4, if there is 5 in a row, where it would turn the first 4 rows. And we've hopefully covered that. Yes, it would match 4 and then move on to the 5th, which would form its own group. Okay. Was there anything else? Was there anything in the chat or something?
Yeah, just right now came in.
Okay, go on.
So regarding other column data, I meant display values for those rows that didn't match to see what their values are.
Display these rows, the hatched out rows, you mean?
Yeah.
Yeah, yes.
I think he means the non-matched ones, yeah.
Yes, got it. Yes, you can see those actually. There is another optional clause here with unmatched rows, which would show you everything. Basically, it shows the entire input table. You know, so even if like you completely stuff up your pattern and it matches no rows, you still get something in your output. Again, that's pretty useful for debugging because you'll get halfway through, change something and suddenly it all breaks and you're like, what's going on? Right.
Yeah, you would just get var, group, and num basically as nulls, right?
Yes. Yeah.
And there's another one that has come in. How to define n-1 rows in the group?
N-1 rows? I'm not sure what you're asking there. You got any thoughts? What that might mean?
I'm wondering as well. Dimitri, could you clarify this? What do you mean with n-1 rows?
Yeah, where does n come from? What's that value? Because I'm not sure where that n comes from.
first 3 of 4 rows, for example.
Okay, so you've matched 4 rows and you want to say just return the first 3. There is a way to do that, but maybe let's save that for later, okay? Because I think we'll need to kind of cover some of the other stuff first. All right. Okay, thanks. Oh, good, yeah, good questions. Looks like, you know, sparking some thoughts and insights here.
I told you, we're just on the first use case.
Yeah, exactly. And I was like, right, you told me, keep it simple, right? Cool. Alrighty then. So that was when we were finding just 1K runs. And just from, I mean, it's hopefully useful for showing you how this works, but I think from like a analysis perspective, it's probably not that useful. There's not that many situations where you're looking like just one of those things like that. So let's kind of move on a bit. So quite often, if you've ever looked up running training programs, you'll know they quite often have some kind of pattern to them. They say things like you should do short runs followed by a long run at the weekend. So some speed training, some tempo training, some distance training. And, you know, there's loads of these. You look them up on the internet and they kind of come up with this, you know, this is what you must do if you want to run 10K in like 60 seconds or something, you know, some ridiculous speed, these training programs. So what I thought I'd do is keep it fairly simple for this is, I'm just going to see, did I have a 1 kilometer run followed by a 5K run? Am I doing short runs followed by long runs, essentially? Super simple training program for me. I'm not going to get into, you know, more complicated things. And we're going to analyze this. So in order to do this, we're now going to introduce a second pattern variable. Okay, so this is when things start to get a lot more interesting in terms of the capabilities it opens up. So let's jump back to the demo. So we've got a 1K followed by a 5K is what we're looking for. So the pattern is 1 kilometer followed by 5 kilometer, right? And in terms of the definition, again, hopefully fairly obvious that we're defining 5 kilometers as the distance equals 5, okay? So again, just like a regular where clause. And we're finding 1 followed by a 5. So the way this works is, as I said, we're working down through the data set according to the order by and left to right through the pattern. So we ask, have we matched a 1K? If we have, we then go to the next row and the next variable and ask, does that match 5K? And that will be the group that we are looking for. Okay, so let's see how that works out here. And you can see we've actually got 3 of these groups. So I've got a 1K and a 5K and a 1K and a 5K again. And down at the bottom, I've also got that group, so all that pattern. So already this is already getting quite interesting, because if I just think about how would I write a query to do this using standard SQL, it's already not that simple, right? You have to do maybe lag or lead, or you join the table to itself twice or something like that. Already it's not straightforward how we would write this SQL without match recognize, right? And this is just searching for 2 different events that are next to each other in the data set, which is conceptually a pretty simple, you'd think a simple thing to look for, but using standard SQL is already quite tricky. But let's make it a little bit harder. Let's say instead of just have a 1 kilometer followed by a 5, I just want any number of short runs. So I want to look and see how often did I do a big chain of 1 kilometer runs followed by a distance run. Okay, so I want 1 or more of these 1 kilometers. So how do we do 1 or more? Well, we do our lovely regular expression again. We just add the little plus operator after the 1 kilometer. So again, that says there must be at least 1 of these, but there can be any number of them. And then we'll stop the group as soon as we've got to a 5K row, one where the distance is 5. Okay, and you'll see now we've got our 2 groups at the top again, like that, but all the rows, all the following rows now group together, go together in this group, because we start this row on the 7th and ask, does it match 1 kilometer? Yes, it does. Then we go to 1 on the 10th. Well, we can keep matching this. Is there one or more? That also matches that 1 kilometer, okay? Well, we can keep adding that to the group. Same for the 11th, that also goes in that group. Then we go to the 13th and we ask, is it 1? No, it's not. We go to the next variable, that's 5. Is it 5? Yes, it is. We've matched the group. Hooray, okay? So we can see now we've matched the entire data set, and I'll just expand this. We can see first 2 rows goes from the first group next to the second group, and the last 4 rows, the num equals of 4, go in the third group. So already, and now if I was then thinking, how would I write this with standard SQL? It's like, okay, this is starting to get really tricky, right? How would I do something like this? I can think of ways, but it wouldn't be pretty, right? You can argue about whether or not match recognize is pretty, but I think they would still be prettier than other things I could come up with. Okay, so that's a 1 kilometer followed by a 5 kilometer. What if I want to find like a 151 pattern? So I run 1 kilometer, I go for a short run, a long run, and then a short run again. So 151, a pattern like that. So let's see what we're going to do here. So in order to do that, I'm going to say our pattern is 1 followed by 5 followed by 1. So there's several interesting things about this pattern that we're searching for. One of the things to note here is you can actually use the same pattern variable many times, in the pattern. So we've got 151. I could keep going 1515 or 115, or So we can reuse them as many times as you need to in this pattern. Okay, you only define them once, but you can keep using them in the pattern as often as is necessary. So we've got our 151. And if we look over here, just in our table, we can see we've got this pattern right at the start. We've got a 1 followed by 5 followed by 1. And if we look in terms of how this matches up, we've got our 151 pattern in the output. And we just got one group here. So this leads to a couple of other interesting things going on here. First up, this 1 and a 5 at the end here. As I said, you have to match the entire pattern for it to be included in the output, for it to be matched. Because there isn't a 1 after this, the whole thing is falls apart and it is not included in the results. Okay, so again, just a general kind of tip or advice: if you've got complex patterns with 4 or 5 variables in them, try and add the variables one at a time. Add the first one, check it works, add the second, add the third. Don't just go straight in and try and write all 4 or 5 of them, because invariably you'll make a mistake and you just be like, what's going on? I don't know what's the problem. If you build it up bit by bit, it becomes much easier to see where you've made a mistake or where it's all gone horribly wrong. Okay, well, certainly that's what I find anyway. So that's one interesting thing. Even though we've matched a partial pattern, it doesn't get included because it's only a partial match. But there's another much more interesting thing here. We actually have 2 151 patterns here. So we've got the one at the start, and then starting on the end of the last pattern, we've got it again. So we've got 15151. Okay, interesting. We've got an overlapping pattern, but we haven't included this second 151 in the output. Okay, well, what's going on, right? Why is that? What's happening there? So, as I said, when we match pattern, by default, we just walk down through the data set. We finished our pattern. We've got 151, completed that. We'll then go down to the next row in the data set and try and start matching the pattern again. So we start on the 6 and ask, does that match 1? It's like, no, it doesn't. So then we keep walking on down through the rest of the data set. And we miss out this 151 here. It's like, that's interesting. What can we do about this? Well, there is another optional clause for match recognize, and that is to specify what to do in this situation, or when we might have overlapping patterns like this. So if I just bring it up, I've got this after match skip to the last 1 kilometer. So by default, this would be after match skip to next row. Just keep going down whatever the next row in the data set is here. This allows us to actually essentially work back and revisit rows we've already processed or we've already included in the group here. So we'll go back to whatever the last row was that matched 1 kilometer. So in terms of this, here it goes. We go 151, we've matched our pattern, job's done. Instead of going to the 6th of March, we then go back to the last row, which had a value 1 kilometer, or match the variable 1 kilometer. That's the 3rd of March. That's 1, because it's 1. And then we repeat the process and we check if that matches it again. So notice we now have the 2 patterns appear in the output, and the 3rd of March actually appears twice in the results, okay? Once for each pattern. So we can see we duplicate it in the output. Really interesting, this is quite cool and powerful. So this after match skip, there's quite a few things we could do here. Rather than skipping to the last 1 kilometer, we could skip to the next row. So having matched these 3 rows and finished a pattern, we could say skip to the next row in the inputs, which would be the 2nd of March, and revisit. And we could do that here as well. But actually, we know, having matched a 151, the 2nd row must be a 5, so it can't be the start of a 151, right? Okay. So we may as well just go to the last row that we actually matched here and retry again. So this is like a little performance optimization, essentially. We might need to skip for to get the correct results, these overlapping patterns, but also it can actually give performance benefit, because instead of, we could go like this, match the 151, then go back to the 2nd of March and try. It's like, well, that's not going to work. Then go to the 3rd, match it again, go to the 6th. Instead, we match the first group, then go back to the last 1 kilometer. That's this one, yeah. Try again, match all of those. And then we go back to the last 1 kilometer, that's the 7th, try those. So we miss out. We never try processing those again, which, particularly if you're going to be matching lots of rows in your group, potentially could be a big time saver, right? Could give some good performance advantages there. Now at this point, some of you might be going, okay, well, analyzing some training data is all very nice. Why would you do this thing for real? This actually does really relate to back one of the reasons this technology was developed. So, and that is stock traders, right? Day traders. They're always looking for these like patterns in stock prices. Like if it goes down 3 days in a row, up a day, down a day, and up a day, they call them W patterns, where price goes up and down, that kind of thing. Apparently, if it does that, then the 3-day moving average is above some value. That means they should buy, and somehow that's going to make them loads of money, that kind of thing, right? I think it's kind of nonsense, but anyway, they're paid lots of money to do this, and they obviously know better than me. But the point here is, this is why we developed this thing, is to help search for those kind of overlapping patterns like this in stock market ticker prices, where the price goes up and down and up and down, and you could have multiple overlaps of those. So there is a genuine reason that you might want to do this. Okay, so just kind of finish on this section here, and let's put them all kind of side by side in the ones that I've just kind of matched. So we've got a 1 and a 5, many ones.
Hang on, Chris, just quickly,
yeah,
there was a question coming in the chat.
Oh yeah, go on.
Does match recognize substitute the where clause?
No. Okay, so good question. Does it substitute the where clause? No. I'll just go back here. You can still have a where clause after match recognize. So I can put all this, I can have match recognize here, blah, 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 and put where after it. And then the where clause filters the output of the match recognize, okay? So it doesn't replace it, it's in addition to it, okay? Yeah, the key thing is match recognize comes directly after the table, the input table. And if you're going to alias it, you actually alias after match recognize. I'm checking. I'm doubting myself now. I'm pretty sure you do that. All right. Okay. Was there anything else, Christian? Before I want to.
No, at the moment, that's it.
Cool. All right. Thanks. So just showing these all kind of side by side. So we got our 1 and a 5.
Yes, something just came in.
Of course it did.
the moment I said yes, it's like,
Yeah.
so, and can you match recognize after joining 2 or more tables?
You sort of. The way
Basically
you would do
on the
that,
result set, I think.
yeah, you join the tables in a subquery and then match recognize the output of that is really the way you would do it. You can join match recognize output to another table, which gets a bit trippy as well, right? This is generally where I think, you know, like common tables expressions, the with clause come in really, really handy. You know, join them in the with clause and then match recognize the output of that. And if you need to join the output of that, again, put it in another named subquery. But yes, you can do all these things, but you kind of need to arrange your subqueries appropriately. This is kind of the answer here.
And another one that just came in. Can we do, here is the data, show patterns found?
Probably, I mean, you need to know what you're looking for, right? There isn't a generic, just find me patterns, I guess. I guess that's what that's asking.
I think that's a reason why you have the naming of the variables actually come back as a column in the result set.
Yeah. So
you can identify it.
Yeah.
And I think another one, which version of Oracle can this be used in?
So this came in 12c, 12.1. So what's that? 9 years ago. You know, come on. If you're not on 12c now, I'm gonna cry. Okay. So yeah, it's been around a while. Okay.
Yeah, and whoever just said we're still on 11.2, don't say it out loud.
Yeah, I know.
You're gonna make Chris cry. Come on.
Cry. Okay. No, I know. I know from experience of working from real jobs is can be difficult to persuade people to upgrade. But yes, please do. Right. Okay. Anyway, so here they all just side by side kind of help you compare the difference between them. And again, the key thing here, when we've got this after match, we are duplicating this 3rd of March row, and we get to, in effect, we get an extra row in the output. If we were, I mean, I know these aren't actually included in the output, but essentially you could get more data, essentially quite a lot more data, in fact, if we had lots of multiple overlapping patterns, which, yeah, it's like you're saying, even when we're talking about this, Christian, is this what you want? What are you asking for? What are you trying to do here? Right. Okay. Right. I think we need to move on because some good question. Yeah. All right then. So we've looked at how I can look for various kind of follow some kind of short and long runs, that kind of thing. So another question that you might have when you're doing any kind of training, I'm talking about running here, but it could be any physical exercise. You want to know things like, are you improving? And when it comes to running, it's pretty easy, really. Am I getting faster? You know, what's my average pace? However, having said that, we probably still want to split it out into short and long runs, right? I know from experience that my average pace when I run 5 kilometers is at least 5 to 10% slower than when I run just 1 kilometer, right? I'm a fair bit slower. And if I just average across every run of every single distance, it kind of gets a bit of a misleading picture on how I'm actually doing. I'd kind of like to break them out into individual distances. So I can get things like the overall total and also get the running total. So maybe I want to do a graph that looks a bit like this. So we've got my longer runs, which I'm saying is anything that over 4 kilometers, and my shorter runs, which is 4 kilometers and under. So we kind of want to split them. We want to categorize them. And there's another interesting thing about this. So in the interest of keeping things simple and easy to explain, I've assumed everything is just like 1 kilometer or 5 kilometers. In reality, I've got a running tracking app on my phone, which tells me how far I've run. That tracks things down to the nearest 10 meters, right? And really, when recording, we want to preserve that. We want to keep as detailed information as possible. So really, when I say a 1 kilometer run, it's probably anywhere from about 800 meters up to something like 1,200 meters, right? It's not exactly 1 kilometer long. So we want to search for a range of values, in effect. And if we wanted to try and do something, we could try and do that using a regular expression, doing something like this. So if you know regular expressions, you'll know this kind of character class syntax. This says 1 or more instances of values between 0 and 4, and then 0 to 95. We could, okay, now this might be the first way you kind of approach this, but actually, this doesn't work for a whole stack of, or there's a whole stack of problems with this, basically. First thing is, with regular expressions, what we're doing is we're matching tokens, so individual characters, individual symbols. So what that means is, if by some miracle I managed to go on a 45-kilometer run, what this pattern would actually match is it would match a 4, because that goes in group 0 to 4, and then it would match a 5. So it would match those as 2 separate entities, right? Rather than lumping them together as a single thing. It's not comparing the values, comparing individual tokens at a time, individual characters, which becomes very difficult when we actually want to do things like compare numeric values here. The other problem here is actually pattern doesn't match what I asked for on the previous slide. I wanted everything that was 4 kilometers and under wanted to be in one group, and over 4 kilometers be in the long run group. If I go on a 4.1 kilometer run, or if I record it in meters, like 4,000 whatever meters, this pattern would lump together everything up to but not including 5 kilometer runs. Okay, so there's a bit of a difference here in terms of what this would do versus what I would ask, and it comes down to how regular expressions work, basically. There's a limitation of them. Next thing is, another reason we can't really do this with pattern matching is, well, it's like we've got some numbers here, but where do those numbers actually come from? What do they mean? You know, what's going on with them? Which columns they come from? Don't know, right? You know, we need to say where they come from. And finally, so those are the limitations of regular expressions and pattern matching. Finally, we might have or want to have relationships between pattern variables. It's not something I'm going to talk about today, but maybe we'll have a session in the future to do that. We can do that with pattern matching. It's very, very difficult to do that with regular expressions. So the upshot of this is you can't do this, right? You just can't do this with a pattern matching. What instead you have to do is kind of push that into the variable definitions. So final set of examples we're going to run through here is showing you how that would work. So I've got short runs and long runs, and I've defined short runs as those where the distance is between 0 and 4, and the long is those greater than 4, okay? So I've got a short followed by a long, and we can see that matches. In fact, this is exactly the same as that 1-5 pattern that I was looking for before, like a 1 kilometer followed by a 5 kilometer. But as I said, on real world data where I'm not rounding everything to the nearest kilometer, which I'm unlikely to do or I don't really want to do, this is probably more what I would want to do. You know, I want to classify things like this. So this is the same as matching 1 and 5, or the same in effect. We've just done it using value ranges rather than specific values. Okay. So having done that, I can then actually group these together to find like my average pace, distance, that kind of thing, by short, whether or not they are short or long. So I can do that by first sorting by distance, and then have this lovely little interesting pattern here. It's like 1 or more matches of the short, or 1 or more matches of the long. Interesting. So how does this work? Well, And again, if we start at the top, because we sorted by distance, we'll start with 1. That will match short, as will all the rest of these. They will all match that short group. We then get to the second, which is the 5-kilometer run. So that does not match pattern. So that ends the group. We start searching for the group again. We have short. So that it doesn't match, 5 isn't short. So the pipe here is the regular expression or alternation. So having not matched that, we'll ask if it matches long. Yes, it does. And they all get put into the group here. Then we will have some information here. So this is where that final one I was going to talk about before. So notice we've got my final pace, so time over distance, and the total distance I've traveled. So this returns the value from the last row in the group. So whichever one that is, we'll get that total for, and we'll repeat it for every single row. So notice these rows here, the short ones all have the same mean, pace, and mean distance, and the long ones all have the same mean, pace, and mean distance. They're slightly different. What if I don't want that? What if I want to get like the rolling average, my average pace so far? Well, instead of final, we could use this keyword running. Now, this is an optional keyword, okay? If we exclude this, we will get the running total so far. This will give me the pace up to for the group in that distance, the running total of the distance. So that's why, when I was saying we had to have final, the final count for the number, that's why I had to have final, because otherwise we'd get the running total. And whoever it was asking about the question, we've got a group of 3, a group of 4, and you want to just return the first 3. You can have match up to 4, have the running count, and then have a where clause, which filters where this column is less than or equal to 3, okay, or less than 4. All right, so that's how you would do that. You have a running total and a where clause after it, which filters on it. And now you can see I've kind of got my my distances and my paces changing over time. Well, distance is increasing, pace is hopefully dropping, so hopefully I'm getting a bit quicker. And then the nice thing is actually I could then split this, so take this output and turn it into a little graph like this. So we can see splitting by my pace how I'm actually doing and compare how that's all getting on. Alrighty then. Any other questions or comments at this point? It's like see who's still like alive and like able to process, or is their brain melted into mush about what's going on here? What about getting a moving average over the last, say, n runs, something like n rows preceding? I'm not sure of a way to do that, and certainly not off the top of my head. There might be a way, but one thing I do know, you can't use the window function. You can't do the over clause inside match recognize. So you could probably actually, that's what you could do. You could do match recognize and then do analytic functions on the outer result of that. Okay, I think you'd have to do it like that, but I'd have to check, to be honest. Can I use both the final and running? Yeah, you can have, as long as you have to name them differently. You have to like alias them. You'll have to say like cumulative distance and total distance, but you could have the running sum and the total sum. Absolutely, you can mix and match between however you want. Okay, as long as the aliases are unique and whatever the expression is valid, you can. There's no restriction on combining those. Okay. Imagine you have a pattern like 1 kilometer plus 1 or 5 kilometer, and you have 3 rows with 1 kilometer, 1 kilometer, 5 kilometer. Will it match? Probably. I think you need to kind of like flesh out the full example to for me to state definitively on that one. One thing I will actually mention that raises a good point. You say 1 or 5 kilometers. You can define define things that are overlapping. Actually, if I just come back over here, if I expand this, if I said distance between 0 and 5, and the long run was greater than 4, then a row would actually match either of them, right? It works top to bottom, so it will match. If this was distance between 0 and 5, anything that was from 4 up to 5 would match the short run first, even though it also matches the long run. You can have overlapping conditions, so be careful when that happens about what the result is. But,
so in that case, the result would be the first one, the short, right?
Yes, exactly.
Okay.
You got it, yeah. Like I say, but if I flip the definitions around, if I flip long run at the top, then it would be the opposite, okay? So yeah, just be careful if you can have overlapping conditions, try not to do it. Easier said than done sometimes, right? Okay. All right, was there anything else before I wrap up, Christian, or?
No, not right now. I think the questions covered all the things that we had in our discussions for this quite well. I think the only thing that that was left is one thing that I remembered from the, when you had the overlapping W patterns.
Yeah.
You kind of touched on it when you said it, but obviously when you do things like this, so if you do like repeating patterns and there's an overlap, and then afterwards you do counting or so on it, watch out that you don't double count your results. So obviously just because the patterns overlap, for example, it didn't run magically like a kilometer more. With the running example, it's very easy. But again, since this comes from the finance world, definitely watch out if you're talking about quantities sold or actually turnovers or so.
Yeah, very, very great point. You need to be very careful with financial stuff, right?
Yeah, exactly. There was one more comment just right now. I think it goes by the order in the pattern, not the order of the define clause.
No, it's the pattern, it checks the variables. There's two directions. It can go both ways, right? One row, the first row could match both variables in the define. The first row and the first variable you've defined could actually have multiple overlapping definitions. Okay, so you need to. I mean, yes, you're right. You will. It does work left to right through pattern. So if you've got one run 5K, it will match 1 first and then 5, or short then long. There are situations where it could actually, it's something we haven't covered. It's when rows are definitions are interrelated, but something could match 2 variables at the same time, and it's not just about the order in the pattern, it's also the order in the define. So you need to be careful, basically. Right. Okay. All right. I need to, unfortunately, I don't have much time to hang around today, so I need to finish up. All right. So we've looked at all this, and some of the like, okay, this is all lovely and wonderful, but why would I ever really want to use this? When am I ever going to do this for real? So what we've been looking at here really is event sequences. Have I done a short run followed by a long run? Have I done 1K followed by a 5K? And we said big reason this actually exists was like stock market price tracking. Did the prices go up, down, that kind of thing? Quite tricky to do this. But also kind of more generally, it's quite often to have like a status history table for things like orders, invoices, support tickets. Let's say you want to find every time a support ticket has been closed and then reopened and closed again, right? You don't, you're not just interested in the final status, you're interested in the chain of events, okay? It is quite tricky to write SQL like that straight out the box. You want to find invoices that were cancelled and then refunded, or refunded and then cancelled and then reissued, or something like that. Tricky to do, and it's finding sequences of events, for me at least, is the real sweet spot for this, because it's super. Certainly if you're searching for more than 2 different types of event, I want a short run followed by a medium run followed by a long run followed by a short run again. It's quite tricky to actually do that. Okay, so this is any kind of sequences of different events. There are also a whole stack of more advanced kind of an analyses that you can do. We kind of looked at advanced grouping a bit, and classifying runs as either short or long, which one do they fall into, finding consecutive rows, bin packing problems, pack goods into containers up to a weight limit or size limit, that kind of thing, and date range gaps and overlaps. We haven't covered any of that at all, really, but it's all there and you can do it. Maybe we'll cover it in the future if you want. Next thing is, just kind of recap on what we covered. So the real power of this comes from regular expressions. However, it's just a stripped down version of regular expressions. You've got the quantifiers, how many you're matching, asterisk, 0 or more, plus 1 or more, curly braces, a specific number, and alternation, the pipe or. I think there are a couple of others, or you've got parentheses as well, so you can prioritize things and group things together. But what this allows you to do is search for sequences of events or sequences of variables. And the key thing here is it has to match the whole pattern. If it doesn't match the whole pattern, it's not included. So just watch for that. And also watch for overlapping, as Christian says, particularly if you do want to show overlapping patterns in your output, make sure you then don't double count things like sales and stuff in your results. So think carefully about what you want. By default, you will not show overlaps. You have to actually ask to show overlaps. And then to kind of look at value ranges or classes, which you would do with the square brackets in regular expressions like 0 to 9 or the letters A to Z, that kind of thing. That's in the definition of the pattern variable. The regular expression classes are not available to you, okay? So just be aware of that. Actually using it in the define clause and the pattern variable does give you a lot more power and a lot more ability to do things, but just make sure you know that. All right, any last questions or comments before we wrap up? Christian, anything else anyone's asked or said?
All quiet on the front.
All quiet, cool. Alrighty then. In that case, like I say, unfortunately, I can't hang around today. So all I'll say is it's great that I'm glad you could all join me. Big thanks to Christian for helping me put this all together and get it all actually working. Please let us know what you think, and I hope to see you next time.